All right, a few seconds late. Welcome to Cooking with Unity. I'm your host, Max Moreau, and today we're going to probably conclude our work on our little side-scrolling platformer here. So first off, I'm going to plug a couple things real quick. I've got some links on the right-hand side in the chat there. I now have an Android version of Proton Pulse available. And for today and actually tomorrow, it will be 99 cents for both the iOS and the Android versions of the game. The Android sale is actually going to continue for 2 weeks because it's the first thing I've ever released on Android, and so I'm just going to give it some legs here, and hopefully people will like it. But yeah, I've got links to all this. We've got it on Google Play, we've got it on the App Store, and it really helps out the show if you buy this app or tell people to buy this app or whatever you want to do. It helps us out. So anyway, done plugging that stuff. So where were we on this? So we've got a game now that where you can jump. Okay, I'm going to wait for this to compile. There we go. So you can jump. We have randomly generated bad things that happen. They're not based on whether I'm jumping or not. Let's see, can I hit? Oh, I barely skirted under that. And you just go right for a while. And our problems right now is, or rather our problems are that we will eventually run out of running space on here if we survive long enough. If I was to pause this and then check where the player is, it's probably going to be sooner than later that we're going to run out of room. So let's see here. Yeah, I mean, we've already basically gone a quarter of the way in, a little bit less than that, but eventually we'll hit the end if we're good enough. Also, right now, we have these blocks that slow you down. There's nothing that actually speeds you up. Oh, that was a cool jump. There's nothing that will speed you up, and we probably want to add that. So there's... Oh, I died. That was horrible. I shouldn't have done that. All right. So, but we have a game. So let's make it so it ramps up the speed over time. Let's try that first, and then once we got that, let's try and fix our non-infinite ground problem. So let's see what we got here. We are going to look at our move right script. So this thing just has a speed, and it just updates your position every fixed update. So, as simple as it gets. What we're going to do is we're going to add another variable called public float acceleration. I've got to have spelled that wrong. Actually, I'm going to check Google on this one. Not that spelling errors are a problem as long as you're consistent, but you shouldn't misspell things. Okay, I guess I got it just fine. Looked wrong for me. If you stare at words too long, they stop looking right. So we're going to set this to a logical amount. I'm just going to go 0.01f. So what we're going to do is just every fixed update, we're going to do speed plus equals acceleration times time dot delta time. So this probably will be too fast. I'm going to actually go 0.01. No, let's just do 0.1, see how it does. We can always adjust it in the game later. And so what this is doing is just changing the speed variable, is adding the acceleration value, and then we're multiplying in time dot delta time. So that means that every second it will increase by 0.1. So we'll go from 1.0 to 1.1 to 1.2 to 1.3. And that, I didn't mean to actually close that window. Let me open that again real quick. My monitors do not like restoring windows to the proper places, so I want to get that done now. All right. So let's hit play and see if this starts working. Let's see if we can notice it. So we're going. And I'm going to try and not hit slow down things and see if we can get going to a nice speed. Let's look at the player in the inspector. So yeah, his speed is increasing. Come on, make it. Oh yeah. Feels so good. Oh no, I'm dead. But it was accelerating. It probably could stand to accelerate a little bit faster, but I'm going to leave it for right now because things are going to get out of hand before they don't. How much do those obstacles actually take out speed-wise? Oh, they take 10% of your speed. That's pretty brutal. So if you hit 10 of those, you'll be at 0, but you'd have to hit them very rapidly. But yeah. It's actually kind of surprising. This is a really stupid, simple game, but there's something to it. Like, just the act of jumping is kind of fun in these games for some reason. Now, we're doing something a little bit different than most jumping games. Most jumping games, the camera doesn't actually follow the player vertically. Like, well, they will to an extent, but a lot of them will actually give them some leeway. Cannonball, there is no vertical scrolling at all. There's just horizontal, and then your vertical placement is just whatever you're at. And we don't have much dynamic for how high you are or anything. So I guess it doesn't matter that much in this case, but it's something to think about if we were going to be improving this game or changing this game around. Yeah, I'm cruising. Yeah, that seems like a pretty decent acceleration rate. I'm happy with it. Alright. So, let's see, what can we do now? Let's figure out our infinite walking space thing. So, there's a few different ways we could do this. One of the ways, of course, would be to, what is it called? Set up the ground to basically spawn another version of the ground at the seam, and then just continue to do that. So it would be basically building it like the level builds the rest of the components. So like if we hit play and go to the scene view, once it loads, you can see this creating these little, that's probably too small to see right now. Let's focus on the player. Oh, the player just died. But it was creating these things as we went along. And so, and as a matter of fact, that's funny. It keeps creating things on the edge of the screen even after the player's dead, but you don't see them, so I guess that's okay. Oh, you do barely see them. Alright. Well, found a bug. You know, there's always going to be bugs. So, but yeah, it'll keep creating those. And so we do the same thing with the floor. The other way is we can make it look like the floor is moving, but have it not actually be moving. And I think that's what I'm going to do first because it's a little bit trickier. And we may switch to the other in a second here, but I want to show you this method just because sometimes when you see stuff moving in a video game, it's not because it's actually moving. Like they can trick you with texture tricks. So that's what we're going to do. What are our texture tricks? So let's make this platform a lot smaller. Come on, give me that platform. Oh, need to be in selection mode. There we go. So it's 100. We're just going to make it 1. And we're going to bring it way over here, negative 500. There we go. That's about almost right. And I'm going to go ahead and make the X scale 2, actually. And we're going to put it right underneath our player. And we have a camera follow script. And really, it's just a follow script. It doesn't actually have anything to do with the camera at all. So I'm actually going to rename it. I'm just going to call this follow. I'm going to call it follow object. Because we didn't do anything camera specific, so we might as well have this be generic so that we can use it for other things, like our ground. So there we go. We're just going to call this follow object. Alright, so we're going to put on the ground. First of all, if we hit play, this will be very short, but if we hit play, you'll see that the ground's there, but the texture looks terrible right now. It's because we still are tiling it 100 times. So since 100 worked when it was at 100, let's just do 3 now that it's at 3 and see if that looks right. Yeah, that looks like what we were doing before. Alright, so we have our ground. And I think that fits within the camera. So if I go to main camera, yeah, that'll work just nicely. Yeah, that's perfect. So we're gonna grab this and clean up the numbers a little bit. We're gonna put the follow thing on here. Follow object. We're gonna follow the player. So on the ground, we attach that, and we grab our player and throw it into the target. And our offset from target, our player is at 490. All right, cool. Y3, Z0. So this isn't going to work right. Our follow script is not going to work for this because here, I'll show you why. If we hit play, the player's just going to be stuck to this thing, and you're not even going to see it actually, but it's there. Like if we just see it traveling, and the thing is, if we jump up with it, and so that's not going to work right out of the box, is it? Offset from target. So the vertical offset, yeah, we're going to need a different follow script for this. Or we're going to need to change our follow script to have more options. So let's look at doing that real quick. So let's do public bool follow x equals true. Let's do this. Follow y equals true and follow z equals true. All right, and let's see. Target does not equal null. Offset from target. So now we need to put some checks in for this. What's an easy way to do this? So we'll just do if actually we'll just make offset from target. No. Alright, we're going to do new position. That's what we're going to do. So vector 3 new position. And we're going to say that equals these things. Transformed opposition equals target transformed opposition. Alright, so we've got our new position. It equals what we wanted it to equal before. Now let's remove... breaking it up like this is kind of weird. I'm going to do it anyway. We'll just work with this, and if I come up with something smarter, I'll let you know. There's probably a lot of smarter ways to do this. So we're going to do so we have our new position. Offset from target, and we want the transformed position to equal. Oh, I know what we'll do. All right, new position dot x. Actually, we'll just put a couple if statements here. If follow x. Actually, if not follow x. equals transform.position. And then we'll do the same thing for the other two. Excuse me. Alright, so, and then we need to change the Y here, and the Z here, and actually this is invalid. I need to actually put an X here, a Y here, and a Z here. So what we're doing here is we're basically throwing away the changes to the position if we're choosing to not follow these things. So if we hit play here, I'm going to disable the script on here just for right now. If we hit play, you'll see the player starts moving and the camera moves with him, and it should work exactly as it did before. So that's working. Now, the ground, we want it to follow the player's X value, and we might as well make it follow the Z value, even though we don't change that. But we're going to not follow the Y, and hopefully this will work. Oh, I still have it disabled. Alright, so I re-enable it. And, oh, we have an offset from target problem. So, what are we doing here? If not follow X... Alright, so the X offset should be 0. The Y offset shouldn't do anything, but it looked like it was. If not follow Y, new position dot Y. Oh, we're not actually using new position. Here we go. New position. Alright, let's see if this works now. Come on. Alright, so it's actually working. It doesn't look like it's working, but it's totally working. See how the units are coming in from the right? So we've got our ground here, and it's totally not moving, it's totally following us. And that looks stupid, but we're getting closer to having an infinite level capable here. So let's, first of all, let's make the ground slightly larger so that we don't have that cut off at the end. And we're going to make it tile by 4. Well, again, where's the tiling? There it is, tiling 4. And now, what we're going to do is we're going to fake this into making it look like it's moving. So the way we can do that is by changing the offset. So if we change the offset of the texture, actually 1 is not a good example, 0.1, you'll see that it slides a little bit. 0.2, it slides a little bit more. 0.3, it slides a little bit more. So we can get away with changing the offset to simulate the movement in the scene. And we can automate that using a script so that it's actually based on the player position. And I think that'll be the best way to set it up in this scenario. So let's give that a shot. What we're going to be doing is create a new script. So create C# script, and we're going to call this one new behavior script. What are we going to call this? Scroll based on target position. Alright, and yeah, we'll just double click on that and start hacking something together real quick. So we're going to have a public game object target, and hopefully we won't need anything other than that. So in the update, we are going to be affecting the renderer on this. So renderer dot where is it? Material dot what is it called? Scroll? No. See, string color main texture. Okay, main texture offset dot x. Okay, there we go. So what we're gonna do is we're gonna main texture offset dot x equals let's do target dot transform dot x modulus. Oh wait, not modulus. Actually, we probably can just get away with saying that. Let's see how this looks. Oh wait, we need to actually attach it to something. And there's an error, so let's look at the error first. Cannot modify a value type, return value. Okay. Alright, equals new vector 2 target transform.x and 0. Let's see if this works now. So the problem was just like most of the properties in this thing, you can't directly set transform.position.x. You can't directly set main texture offset.x. You have to actually give it a vector that has that information in it. So hopefully this will actually compile now. It's not going to work yet because it's not attached. Nope, it's still a problem. Oh, that's the problem. Transform.position.x. I'm going to hit play again. And is it working this time? It is. All right. So now let's actually attach this script to our ground here, and let's hit play and see what happens. This may actually do the opposite of what we want. No, there's no rigid body attached to the ground game object. Weird. I don't know what that's all about. We'll figure that out in a second here. It's happening every time we touch the ground. We'll figure something out with that. So scroll based on target position. Do we have a player tag on here? Yeah, we do. So I think we're doing this actually the opposite of what we want. So let's It's kind of weird, honestly. What is the ground status doing? Oh, we didn't actually attach a follow object. So we need to actually do that. So, well, we didn't actually attach the script. It doesn't even look like. Huh. Alright, let's do that again. Scroll based on target position. There we go. And now let's attach our player into the script, and then let's hit play. Alright, so it's going in the wrong direction, and it's going way faster than it needs to. So we're going to have to play with our math a little bit, but at least the theory seems to be working. So let's go back into our script and see what we need to do. So first of all, it's scrolling the wrong direction. And we were just being lazy. Well, I was just being lazy about this before, so now we actually have to do some math. So what we want is we really just want the last two digits, like not the last two digits, sorry. We just want the decimal place for this, because when this becomes 1, Basically, here, let me show you in here. So the offset is, if we do an offset of 1, it looks exactly the same. If we do an offset of 2, it looks exactly the same. It only matters when we do like 0.1 or 0.2 or 0.3, because each one means that it's scrolled the full length. Actually, that's interesting. 0.9, 0.1, 2, 3, 4, 5, 6, 7. Yeah. So it'll go one whole tile when between 1 and 0. So I was cheating this time because I was just feeding in the transform position, which is fine, because if we just wanted if we just fed that in, whatever this position will be, it'll have a point value in there, and so that's what we were getting. But obviously that's going way too fast in the wrong direction. Actually, it might even be going the right speed, just the wrong direction. So we really just want the inverse of, like, if we had 0.9, we actually want 0.1. So let's look at what we can do for that. So all we're going to do is, how do I get just the, I know what I can do. I will subtract the integer form of it. So let's make it a value here. Float offset, and float offset is going to just equal target dot transform dot position dot x minus target.transform.position.x converted to an int. This is probably not going to work as well as I hope. And then we're going to actually use the offset here. And I'm just going to try this first because I'm curious what this is actually going to do. Hopefully it will do what I want, but it probably won't. So hit play, and we look at our ground, which we are already looking at. Come on, play. Alright, so it's still going the wrong direction, but it looks like it's doing the thing that we want it to be doing, which is mimicking that component. So maybe it's not. We'll find out if I'm maybe going to be able to do this right. So now let's take this answer and subtract it from 1. So 1 minus target transform, and see what this does. It will be a miracle if it just works. Come on. Okay, yeah, it's still moving way too fast. But at least it's moving in the right direction now. So we're getting closer. We're getting closer. So I don't know how this factors into it, but I'm going to pretend that it does. Let's actually take the scale into account. So it's 4. I'm just going to hard code it in here. We're just going to divide this whole total by 4. And yes, this is how I do all my math. It's just guess and check. And then when I get something that's kind of close, you saw me butchering math on the what was it, tower defense game. Well, now I'm butchering math on this game. Oh, that was getting closer. It's like the right rate, but it's, yeah, I know what's going on there. Alright, let's look at this a different way. So we're going to make a private float offset, and we're going to let's see, private float last target position. And we'll just calculate the offset. No, we'll keep the offset. No, we don't need this. This is not needed. Alright, so what we're going to do is, in the update loop, we're going to need the start thing now. So, void start. And so last target position equals target dot position dot transform dot position. Alright, so then what we're going to do is we're going to figure out the offset. The offset is this is a float. So we're going to do dot x. We only care about the x. So last target position, that's the dot x component. So we're going to do offset is target dot transform dot position dot x minus last target position. And this time we are going to, this is probably not going to work, but I'm going to try it anyway. We're just going to do offset.x plus equals, I just want to see if this works first, but it's probably not going to work because this is a property, plus equals offset. So let's see what this does. All compile errors must be fixed. Yeah, that's what I thought. Yeah, cannot modify the return type. Alright, so what we're going to do instead is let's just undo here until we get back to there. Alright, so we're going to do main texture offset. Actually, we can just do plus equals on this because we're doing 0 in the second component anyway. So yeah, let's give that a shot. And my computer's thinking. Here it goes. Alright. Still scrolling way too fast and kind of going erratically too. Look, it's so easy. This is totally the way to do this. Yeah, that offset's going real fast. Should it be going that fast? Oh. Duh. Wait, no. Oh. Yeah. Alright, so we do that, and then we set last target position to the current target. Position.x. And actually, I'm going to do x position. So that it's explicit that it is just the x component. So we're going to hit play. And hopefully this will work a little bit better. It probably is going to be going in the wrong direction, but it might be going at the right rate. So, no, it still seems really fast. This is constant now and not over fast. Alright, let's do our divide by 4 thing now. And let's do minus equals. And let's see how this works. Alright, there we go. That's looking right. No, it's looking a little too fast. Huh. Oh, that's right. These things aren't 4 long. They're way longer than 4. How, that's our problem. I was assuming that the planes were single units, but these are actually much larger than one single unit. So, like this one is, this one is So yeah, I think they're 10 units per. Alright, so that actually makes more sense. Let's, it doesn't actually matter where this thing is, but actually it does matter where the player is, so let's do that real quick. So maybe divide by 10 is what I need. So this will actually get rid of the change in units between the texture and the actual object itself. Let's see if this actually does it. Alright. This might be it. Let's see if it looks right. It looks right. Look, they're scrolling at the same rate. You can actually see that the parts above and below the blocks here have the appropriate speed going on. Alright, so that was our problem. Our problem was if we just create a plane, I'm just going to do this real quick. Create a plane. I'll just do a quick comparison. So this is our plane. If we actually create a cube, you'll see that the cube is much smaller than the plane. It's actually 10 times smaller than the plane. And so that's why we were getting a discrepancy in our math here. So that's what this 10 represents. It represents how much bigger the plane is compared to a 1 unit object. These are the kind of details you have to worry about when you're doing fancy stuff like this. But I wanted to show you the fancy stuff because scrolling textures are incredibly useful for this kind of thing, and you can really fake a lot with them. I'm going to actually go back and show an editor how this actually looks now that we've got it working right. Come on, delete this. Stop beeping at me and delete. Alright, so if we hit play, we'll actually see that we're on a magic carpet the whole time. See, there it is. Doesn't that look cool? Oh yeah, pressing space doesn't do anything when we're not in game mode. So yeah, I'm actually going to pull the game window separate here real quick. Sure, let's put it here. Oh, I didn't load my save script. Let's actually do that real quick. Because I haven't saved. So let's do the simple autosave thing again, put it back up wherever, and let's manually save right now. Naturally. Because I'm running. So we hit save. There we go. And now it's saved. So I've got the game window here. That's kind of a weird place to have it. It's good enough. It'll allow me to at least jump and do stuff. So, yeah, you can see that we're on this magic carpet that actually is just, it looks like we're actually building it as we go along, but it's just moving with us, and the texture is moving in such a way that it looks like it's staying still and just building in place there, which is exactly what we want, because when we have the camera moving, it looks like we just have this infinite platform, and we really could play forever now. That's not entirely true. We have a problem here, and you can see it in the editor window here. Even after we've left the area, these objects are staying around. They are just going to stay there forever. And eventually, it'll take a long time, especially on a computer, but eventually we're just going to run completely out of room. No, that is a tough situation. I guess you have to bump it on the side. See, we get to discover how to play the game, even though we designed it. So here we go. What are we doing? We've got this missing reference exception. I'd like to clean that up. I'm going to put the game back over here again. We had a couple of things that I wanted to fix up here. Oh yeah, what I was just talking about. So let's clean up the objects as they go off the screen. So we've written this script before, but I'm just going to write it again. Destroy on invisible. Now, all this is going to do is, and I'm going to have to look up the actual script name, so on invisible Unity. On became invisible. Okay, so that's what we want. So we want, let's It's a really short script. Void on became invisible. Destroy game object. Simple as things get. Alright, so we're just going to attach this to things that are appropriate to attach this to. So we want to get rid of it on... So we want to definitely put it on the blood cube, the obstacle, and the spike. Now, this one's a little bit trickier to actually test, because if anything has a camera looking at it, it's going to keep staying around. So we've just jumped a few things here. I'm going to check the scene. Okay, so if we go back into the game and go back into the scene, you'll see that things are... Oh, wait, do they actually destroy themselves automatically properly now? No. If I'm looking at it, you won't be able to see it, because any camera looking at it will make it so that it counts as not being invisible. So if you have a whole bunch of cameras looking at one object, it has to go out of all of their ranges before on became invisible calls. So, but if you see here, if I run for that was a terrible example, but you saw there was a yellow one and it's gone. So that's good. So it means it's working. And you notice the blood cubes actually go away when we do the exploding blood cubes now too. So when we start walking to the right, if I die, you'll see a bunch of them appear and then some of them will die. And actually, that's how we can see that these are working. So we've got this obstacle clone. There, it went away, and now there's a new one. Oh, found a bug. So yeah, if you jump on this thing and bounce off of it, didn't quite get enough range on that. If you bounce high enough, we can make it go off the screen at the bottom, and then they disappear. So that's it's very Mario Brothers. Just not caring when things go off screen. It's like, oh, there's off the screen, so it's gone. But yeah, so that's a bug. I'm not going to be fixing that for this episode. What else can we do here? First, let's fix up what's going on here. So, missing component exception, slow down and fall away. If collision.collider.tag. Wait, why is this having trouble? Obstacles should have rigid bodies, right? Yeah, they have one. So I'm gonna hit play again. I'm gonna go to the console. Oh, I didn't want it to maximize. Why did it do that? So it's getting that attached to the ground game object, but the script is trying to access it. Do I have, like, slow down and fall away on the player for some reason? No. And Unity is acting up with me tonight. Alright, so let's try and figure out what's going on here. So the ground, I mean, it shouldn't have a rigid body. Slow down and fall away. Why is this on here? Okay, that was it. That was totally it. So now it's clean. Let's make sure that everything still keeps operating. Okay, I have no idea how that script got on there. But that was the problem. So now we're getting misreference exception when we die. That's because on our not the follow object script, but on our scroll based on target position, we're not checking to see if the target is alive. So if target does not equal null, then we do this stuff. And that should get rid of that one, and then we will be error-free for right now. So here we go, we hit play, we wait for a while it compiles or whatever it's doing. Alright, so here we go again, smoothly scrolling to the right. I know it doesn't look smooth on the video. And I'm just going to get myself killed, so I ruined an opportunity there by scrolling a spike off the screen. Here we go. Bam! Blood cubes. No errors in the console. Looking good. Alright, we got 14 minutes to wrap this up. Let's see. Get out a scrolling background. I might do that. Let's do this first though. Let's make this game have a score real quick. So we're just going to create. Actually, let's save. Let's create a empty game object. Let's call this the score manager. And we're going to create a script called score manager. Script score manager. And we've done this once or twice before. I'm just going to quickly mock it up. So what we're going to do is we're going to need a public let's have public float points per second. Actually, let's make this let's make it points per second. Let's make it a float. No, let's make it int. And then we're going to have private int score, private int high score, private static int high score. And so on start, we're going to make, actually, we're just going to set this as 0. We're going to set this as 0. And in the update loop here, I'm going to do public game object. This is going to be a cheap way to check state. Player. And actually, let's not do points per second. Let's do points per meter. And so this will allow us to track what this will allow us to track how fast the player is moving and stuff. So what we'll just do is in the update loop, we will add points to our score based on points per meter and player position. So we're going to do another private float. What did we call it before? Last target X position. So last player X position. And so we do need the start thing after all. Void start last player X position equals player.transform.position.x. So we're going to need to do this at the end here. I'm going to remember it right at the beginning this time. And so on the update loop, we take however far the player has gone and turn it into points. So we'll just do float distance traveled equals player.transform.position.x minus last player x position. And then we do, I'm going to actually make a little function called public static. We don't technically need to do this, but it'll be more useful if we want to add score in other places. Public static void add points. Oh, that's not going to work as a static void. Okay, we're just going to do void add points. We're not going to worry about being fancy. So add points, we'll just do score plus equals points. Score plus equals points, and if high score, and actually I want to make that look better. If high score is less than score, high score equals score. And so then we're just going to do that here. We're going to just do add points, point distance traveled times points per meter. And we're going to make this default to something logical. So we're going to do, I like big scores, so we'll do 100.0f. Oh, wait, sorry, 100 points per meter. And we're going to need to actually make this an int, so int, because that's what it expects here. And then finally we need to display the score. So we're going to do an onGUI real quick, void onGUI. Hopefully I capitalized that properly. And I forget how we do this. GUI layout dot label so I think we just put in the content here, so points. Let's see what this actually does, see if we actually get points on the screen. Compiler errors, of course. Points does not exist in the current context. Oh, points. We want score. Alright, oh, int, so we need dot to string. Come on, eventually this is going to work. Alright, it worked, although we aren't seeing any GUI stuff. So let's look at a quick GUI layout example on the internet. GUI layout. I like searching Google more than I like searching Unity's own website because their search is slow. Make an auto layout label. So if we want it, all we need is like, let's see, text. So that should have totally worked. Function onGUI. Let's look at C#, make sure that we're not doing anything funky. GUI layout dot label void onGUI void on GUI, GUI layout.label. So why is it not actually... Oh. Didn't attach it to anything. So we attach this to something. I'm going to put it on our score manager that we made. And I'm going to make the score manager at 000, even though that doesn't actually matter. I just like to do that for some reason. So hit play. There we go. We have a score. It says 0, and it's going to forever say 0 because of the way that we're calculating the points. This is actually a really common problem, so I'm glad I ran into it. So what we're doing here is we're doing a little bit of math here. Distance traveled times points per meter. So the distance traveled is going to be very small between updates. As a matter of fact, it might be 0 at times. And the problem is we're converting this to an int, which doesn't actually round up or round appropriately. It just cuts whatever is at the other end. So if we never get above 1, we'll never actually get any points added. I think that's the problem that we're getting right here. So let's actually change this so that let's just make the score a float. And let's make the high score a float. And we can display it as an int. So we're going to change all these things that say int to float. And let's see if this works first off, just right off the bat. We'll probably have this decimal place, but we'll get that fixed in a second here. Generally, people don't like decimal places in their scores. I don't really think there's anything wrong with that, but, actually, that wasn't the problem at all. The very old player of Score Manager has not been assigned, so it doesn't even know things have been moving. So I'm going to, that's not what I wanted to do, nor is that. Edit, undo player parenting. We want player to be in here. Alright, I'm still going to do it this way, though. So if we do... do int here. Let's see if that actually works. I don't think it will, but let's find out. Come on. Oh, I have an error. Yeah, it totally didn't work. Okay, let's just do this for right now. Just so that we have it working. Alright, so it's working, and we're getting points. And so yeah, we have that. Let's actually get our high score printing as well. So we'll do the same thing here. High score. And there should be, okay, so let's actually make it say score, score, and a plus here, and then we do the same thing down here, except for we do high score. So now when we hit play, we should get text that say score and high score. Alright, so we get our score and our high score. I'm going to get killed real quick. So we get killed. Bam. Score stopped. We need to check for null on one of those scripts. And then we hit enter. And the score's going and the high score's not because we haven't reached it yet. And as soon as we reach the high score, it should start going up with our score. Sweet. That's awesome. Alright. What else are we doing? So let's fix that problem. So we do if player does not equal null. So this will get rid of that little problem. So now when we die, we shouldn't get spammed with all these errors. And it's 9 o'clock, so I'm just going to go a little bit over just to clean this up because I want to get rid of that decimal place, honestly. And I think there's an easy way to do it. I just need to do a quick little lookup to find out how. Alright, so we want to die. Alright, no errors that time. And everything still seems to be working just fine. So let's get rid of that decimal place real quick. Let's look at toString. Let's see. Float toString C#. We're just going to search for that. Alright, so float and C# is single, so you can definitely do this. R, I don't know what R means. Oh, that makes it easy. Let's see if that works. So we'll just do quote 0 and quote 0. And hopefully alright, so that worked out real quick. So you can just kind of specify the format with the zeros. So if we wanted like just a point, like if we wanted to have decimals but just one place, we could actually put a 0.0 in here and 0.0 in here, and it should give us just one decimal place. I actually didn't know that you could do that for the format specifier, which is really cool. I figured I would have to put like D or something in there. So, and that probably works too, but yeah, so that works. So let's go back to the way it was. Let's look at the screen for a while just in case my encoder didn't do a good job of showing what we're doing. And all right, so that's our game. I wanted to have some time to put some sound on this, but we didn't. I want to do another project with sound, definitely. Maybe we'll focus on sound for the next one. Thank you for joining me. So, what was I going to say? Remember, email me at pushypixels@pushypixels.com if you have any questions, comments, concerns, and ideas, whatever. I just like to talk to people. If you talk to people who have emailed me, I'm easy to talk to. I just like talking. So, and then the other thing is Proton Pulse. Buy it. Proton Pulse. Oh wait, that's not what I want. Ignore this. Just ignore that. Where is it? Proton Pulse. Normal view. Proton Pulse. Alright, technical difficulties aside, yeah. Buy Proton Pulse. If you have a phone, pretty much you can buy Proton Pulse now. It's on Android and it's on iOS. And it is 99 cents for today only for iOS. As I said, I have a special 2-week deal going on for the Android just because it's my first app on Android. And thank you very much, and good night.